Hello and welcome. What we will be talking about, it's the tooling API, what it is, how you can use it, and what can be done, and what we are doing to help you to get some insight into a Gradle build and integrate with other tools that are part of your ecosystem. So, Szczepan, how long are you with Gradle?
Nearly 4 years with Gradle. So, hang on, I need to talk to the mic. So, nearly 4 years with Gradle, and I'm enjoying it every day. So, Radim is our Prague contingent. So, because we have this deal that we hire developers in different countries, so we can't have 2 developers in the same time zone. It's just against our internal rules.
Time zone is okay.
Yeah, it has to be different country. Yeah. So, I'm in Krakow, Radim is in Prague. And Radim is doing a lot of tooling API stuff these days. We are investing more and more in tooling API. And some of that stuff you can see in the Android. Anyone uses Android plugin? Oh, nice. So a lot of tooling API godness is happening because of the tooling API. So.
If you want to learn about tooling API, you can start with our user guide. That's really useful source of information about anything what is related to Gradle, and there's a chapter dedicated to that, but I think it wouldn't make sense to read that. And yeah. The basic idea is that we have that API as an official supported way that you can use to collaborate with Gradle and be called with some external tools. And that's how we want to expose the internals from Gradle. To make sure that this is working, we need to define some known entry points and say, hey, those are things that are officially available for you and you can use them. There are some restrictions on how these things will work, and one of them is that if you are using tooling API to access Gradle build, it will work in a way that your application uses tooling API, its jar file is embedded in your application, it will run some code inside your application, but it will talk to a Gradle daemon. Some usages. The first one is IDEs. The other one is probably things like continuous integration servers, similar stuff. Another one is testing your own plugins. That's something what we can discuss later. If you want to create integration tests for your plugin, tooling API can help you with that. Sure.
So I want to say a few words about historically why tooling API is architected this way. So we decided that the tooling API should have this sort of a client-server architecture, or more like a consumer-provider architecture, because back in the days where the first initial APIs in the tooling API were designed, we thought that it's not enough to just deliver you interfaces that you can use to embed Gradle. We wanted something more strict. We wanted something that will prevent backwards incompatibility issues. We wanted something more stronger to give a better user experience. For example, for the IntelliJ users or Eclipse users that use tooling API. Now, there was a consequence of making that decision in the tooling API, and the consequence was that it was expensive to add new features to the tooling API. So when, say, Eclipse team or IntelliJ team goes to us, hey guys, we need this piece of information, we always need to add this information to the tooling API, ensure it's forward and backwards compatible, and that was the trade-off. So that we had to allocate resources for that. But later on, we're going to tell you what we did to tackle that consequence, to ensure that we still maintain backwards forward compatibility, which means a really nice, convenient, and no errors when you use newer Gradle versions. Yep.
One, do you take questions? Okay.
Yeah.
You mentioned one use case being CI servers using it. Do any of the CI servers out there use it?
Okay, so the question is, do CI servers use tooling API? As far as I can tell, I think the Jenkins plugin is integrated using tooling API. It's calling the Gradle build using that API, I think. I cannot say that TeamCity is using that because I don't have sources available or nor the knowledge from those people how that was done. But I expect it can be using that. Okay. What do we offer? There are 3 basic things that you can do when you get a connection to a Gradle build. One of them is you can run a build. If you know the task name, if you know some other information that is needed to call a build, you are able to start the build and see, okay, it's processing. You can see the output, the standard output, standard error. You can pass arguments, parameters, stuff like that. You will get the result. That's something what you can assume, yeah, that's the thing. I have a build system, I want to build something. The other part is you can get a model. And what is a model? Model is something what we are providing from that build for you to give you a picture what Gradle thinks about that build, what it thinks about some of these aspects of that build. The typical use case that we mentioned at the beginning was IDEs. So what does Gradle know about the project setup so that we can create matching setup in your IDE so you will be able to develop that project. And since the early days of tooling API, there was a Eclipse project and IDEA project. So those are 2 often used models exposed by that tooling API. And those are evolving over the time. And we will talk about that thing that Szczepan mentioned. How do we do that evolution in a way that various version of tooling API can talk to a different version of Gradle build with a backward compatibility and with a forward compatibility. Like the older version of tooling API can talk to a build which is using much older version of Gradle, but we expect that it will be possible to talk to a build that is using a newer version of Gradle. We have a set of models that are built in, and those are part of distribution. That's really nice, fine, okay. We have project structure that says, okay, root project, what are the children? Okay, we can recursively scan the whole structure. We can see what are the tasks for the project, other things. We are exposing publications from those projects. That's another thing that was requested. All the models from our tooling API that is shipped with Gradle. There's a possibility to inject your own custom models, and that's basically the key thing behind the current implementation of Android support. Because at the moment, the model that is used by Android support is really very different from the IDEA model. So it's not possible to use the IDEA model directly. And the guys at Google have created their own model, and they are using that together with the IDEA model to build their view and their project setup. Of course, if your use case is different, you will be able to create a different model. Okay, there's a question.
Yeah.
So the question is, if the tooling API is using daemon, does it mean that Eclipse or IntelliJ will use the daemon? Well, in fact, it does. So what's happening there is, if you are importing Gradle project into IntelliJ, it does that request through tooling API, give me the idea model, idea project model. As a result, it starts a daemon process. You probably don't have to notice that, because as far as I know, they are running that daemon and passing some parameters to have really short timeout. So, and the reason why they want these short timeouts is somehow related to the fact that they are using their own init scripts for that build to inject some things. That's a topic that we will discuss later in this talk. Okay, the third one, execute an action. It's a little bit special, and basically, I believe this was added as a way how you can collapse several requests into one action that will be run in that Gradle daemon and do something. So with an action, you can say, I would like to get few of these models, and I don't want to pass those requests sequentially just to reduce the overhead. Or I can get some of these models and do some filtering on that daemon side just to make sure that it's effective and my client gets just the needed information. I think NetBeans integration uses that when it asks for basic Gradle project together with IDEA project and with Android, and then it's just getting back everything what was obtained. Yeah, I will send back. If something is missing, never mind. I will get all the information that I can get, and it will be just one request.
I want to say a few words about the model still. So traditionally, tooling API had only Eclipse and IDEA models. And if you look at the APIs and interfaces available in tooling API, you're going to find out that about 90% of the interfaces are related to IntelliJ or Eclipse. And now imagine the situation that there's an eager contributor that wants to create a NetBeans integration, right? And hey guys, I need a model for NetBeans, right? The model is tailored for the domain, right? The API of that model, the methods, the properties of the interfaces are specifically tailored for that particular domain, Eclipse, IntelliJ, or NetBeans. And well, we didn't have resources to provide him that model. So basically, the NetBeans integration was using IntelliJ model, right? So you can see that this wasn't working for us very well. The fact that the tooling API has fixed models and the API is tailored to the domain. It would have worked if we had a lot of resources, a lot of developers that could provide that information. That's why we have custom model. This is something that changed everything in the tooling API, and that's the great strength of the tooling API.
Yes. Thinking about that problem, you can say, okay, our customers are IDEs, so we will create a common model for all of them. It's the same domain, it's IDEs, so they should be able to live on the same thing, but the reality is they don't like that. So, yeah. And then if you do that common denominator for all of them, you are probably losing a lot of stuff. So you want to be specific and say, if you want that information, okay, we need to find a way how to do it correctly. Okay. So we went through that section where I try to explain what you can do. So running a build, getting a model, or maybe mixing those together, or doing several of these tasks at once using an action. Now, how it works under the hood, because you can use it without knowing all these details. On the other hand, if you have an idea what will be happening behind the scene, it can help you to use it more effectively. So tooling API itself is a self-contained jar, and we are trying very hard to keep its dependencies very limited. I think it depends on Guava that is repackaged somehow, but it's still a relatively compact jar, and yeah, the only thing is probably we are using SLF4J for logging, so you will need to put some implementation on a class path to make sure that the log can be processed. In fact, I'm wondering, we don't really need to release tooling API on the same schedule as Gradle itself. It can be used independently. But for the simplicity of the process, we are releasing new versions together with new version of Gradle. What's going on when you start using tooling API? So the main entry point is Gradle connector class that contains a static method saying create a new connector, and there are a few methods that we will use to customize. Okay, I want a connector that will tell use Gradle of this version or from that place or something. Once you are creating the connection, the tooling API will make sure it knows where the Gradle is and that there is some Gradle installation. So there is one step that is not mentioned on this slide, and this is, okay, if the installation is missing, I will get it from distribution URL install and start using it. If you say, okay, I want to use Gradle installed in that directory, I will use Gradle from that directory. Once we know that, once we install that, if necessary, we can dynamically load some classes from that installation into your process, and that's the key thing that allows us to do cross-version support. Because we gave you that tooling API. That's really a thin layer that gives you the access to the Gradle. And now we get the implementation that is required to talk with that Gradle daemon, and this implementation is loaded into your client. And of course, it takes some effort to make sure that that implementation is done in a way that, okay, if we have tooling API from the current release of Gradle, which is now 2.0 release candidate, and we load an implementation from Gradle 1.1, which is still supported, I believe, or 1.2 is supported in Gradle 2, then we will only use things that are known to work in that older version of Gradle. So that's what we are doing to make sure that, okay, not only we can use the same version of Gradle as is the version of tooling API, because it doesn't make really sense. We created Gradle in a way that you want to stick with a version of Gradle because your build is now working correctly with that, and you don't want to destabilize your build. So yeah, that's what's in your Gradle wrapper, and that will be used by tooling API as well.
So a little bit on forward compatibility of tooling API. So backwards compatibility is fairly easy, right? It's like in Java, right? You have some code that will work with a newer version of Java. Now, in tooling API, because it has this sort of a client-server architecture or consumer-provider architecture, we need to also consider the forward compatibility. Basically, what it means is that a tooling API client, the consumer as we call it, it's a bunch of interfaces. Imagine that in one version of Gradle, let's say 2.0, we introduce a new method to one of the models, to the idea project model. We have this new method. Obviously, this new method in the client code will be supported ongoing in the future versions of the provider, of that server stuff. But the forward compatibility means that this new method will also work in a reasonable way with the old versions of provider and server. You see that the certain version of the client will not only work with the newer versions of the provider, but also is going to work with the older versions of provider. It does not mean that it always will give you reasonable results, because in old versions of provider we might not have that information available at all, because it uses some old version of Gradle. But the result is going to be reasonable. It's not going to break the world. You're going to have a reasonable exception saying, hey, this information is unavailable, or we're going to invent that information based on, or approximate this information in some way. So this is really fancy stuff, the backwards and forward compatibility and tooling API. And I want to show you a test, how we test that in Gradle. So I'm going to just open really quickly Gradle project. And I'm going to jump quickly into the tooling API submodule to the integration tests. Some of the packages as we have here are named accordingly to when we work on that. But for example, you can see that in those integration tests, we have annotation that describes at what target version this test should work on. We also have, let me find some other tests that show the minimum client version. IntelliJ is not supporting me very well. Come on, show me some. I can't find it now, but in theory, you'll find it? So in our test infrastructure, we have ways to describe and annotate a test, that it should work on certain versions of target Gradle versions and certain version of client, certain versions of the client. And then on our CI servers, we run this particular test, this particular feature on permutations of those versions, on combinations like 1.5 client works against the 1.6 server, 1.7 server, 1.8 server. So we have a custom runner that basically runs those tests against different provider versions, different Gradle versions. Hopefully it makes sense. Any questions about that maybe? No, it's really cool stuff, yeah?
Is that using the Spock extensions then, or is that
This is
doing a custom annotation thing with that?
This is using JUnit runners.
Can you repeat the question?
Oh, okay, sorry. The question was whether it's using the Spock extensions.
Yeah, like you basically define your own custom
Yeah.
runner and extend it.
This is using JUnit runners, but we really like Spock and do use Spock. Yes, but I'm not sure what is the reason why we use the runner. Maybe we already had that infrastructure and it was easier to use the JUnit runner. But it's really cool that we can basically have a coverage, and then we can annotate those tests with a given version of the client and server, and those tests are executed against that stuff.
So, is it using JUnit categories?
No, not at all. Oh, sorry, yeah, the question was whether it's using the JUnit categories. No, it's not using the JUnit categories. Those annotations are our inventions.
Okay. I think we got a little bit sidetracked. We will have to get to the code, because now it can seem a little bit difficult to understand. Okay, so I have a simple project where we can show some of these things, how you create your own custom model. And the idea was that I would like to visualize some of the dependencies of your projects in a different way than what you see if you run dependencies inside or yeah, that's the task name for that. So the initial version of that code is on a GitHub repository that I have under my account. And let's open that in IntelliJ.
Just go with one.
Close.
Yep.
Okay, I will quickly say what's the first step that we will go through as this project is created and changed in several steps to get into some reasonable shape, or at least to see some complete picture of how do I use tooling API. So at the beginning, we will create a multi-project build, which is not a one build, but it will be two builds. One of them is the real project. There will be sub-project building the model and using the Gradle APIs to provide that model from Gradle. There will be the second project, which is the client side, and that will use the tooling API to call Gradle build and get the model from it. We will also create the third one, which is just a sample project, so that we can have something to test that stuff on. So I will start with the latest one, which is the simplest. Okay, that one is empty. And build says, okay, I will use Java plugin, and I will have some artificial dependencies. We don't have any source code because it doesn't matter at the moment. What we see here is we have a build script section. Why do we need that? So what we will be doing is that we will create a special plugin, and the role of that plugin will be that it registers our model builder into a Gradle. And through that model builder, Gradle will know that, okay, if I get a request for model of some unknown class, which is not part of Gradle distribution, I can ask all the registered model builders and say, hey, can you build that model for me? And if you can, yeah, so please do it, and I will return that through the tooling API. So we will need that special plugin for that collaboration, so that the build can return our model. In a later stage, we will see how to avoid that problem. So to install that plugin, we have the build script section saying, okay, we will get the plugin from a simple repository created as a publication from the other project. And that's where we apply the plugin that we are now developing. Let's take a look at dependency client, because that's what will be using our new model. It's not really complex code. It will be something like that. We will create new connector. That's the entry point for the whole tooling API that I mentioned earlier. We will say, for the project directory, and we will pass the project path from the build script. So we will be questioning the build in that directory, connect to that build. Once we are connected, we will ask for our model, and yeah, we will start with a simple hello world. Okay, so what is our model? It's just an interface. Say hello. It has to be an interface. That's one of these requirements in the tooling API. What is provided as a model has to be an interface. There are some reasons why we are doing this in this way, but yeah, I don't think that's too restrictive. Okay, now how can we implement that model? I said we will have a plugin. This is a plugin. Many of you, I believe, have seen how to create a simple plugin. So there's a dependency injection going on. We will need model builder registry, so we ask for that. When the plugin is created, we get the instance, and this is where we will register our own model builder. Now, what does model builder do? I said that the way how it works will be Gradle needs to answer the request for a model of some class. So we will call all the registered model builders. Can you build that model for me using model name, which is equal to a class name? If we respond, yeah, we can do that, it will call our build all method, and that's what we will need to implement.
Can you describe the string being passed in for build all?
The string parameter is basically a symbolic name for that model, and at the moment the convention is that the model name is a class name of that model. At least that's what all the existing models that I'm aware of are doing. You can do some tricks like having more model names and implement that with one model, but yeah, it can get probably a little bit tricky to get that. So let's take a look at dependencies model. Because that's the interesting part. It's dependencies model. We are asking for configuration dependencies model. I said configuration dependencies model is an interface with one method, say hello. Now what we see here is a class that implements serializable. That's not configuration dependencies model. Why not? So the idea here is we don't require that you will implement your interface here. You can do it. But for the purpose of achieving backward and forward compatibility, we are dropping that restriction, and we will do some magic behind the scene to make sure that, okay, you give me some instance, and we will do the rest of that heavy lifting to transfer your object from the Gradle build to your client where it should be used, and we will make sure that, okay, if you asked for that interface, it will behave as that interface. So what we will do is that using serialization, we will send that instance to your client. Probably not that difficult. Well, it can be. There are some things that you need to consider, like make sure that both sides are compatible. And serialization, yeah, it works if you know how to use it. So we will send it through serialization, and on the client side, we will wrap it into a proxy object that will make sure, okay, now it behaves as the interface that you asked for. That's part of that reason why we need that your model will be an interface. So the documentation says basically the same thing. Why we are doing that? I said that's for that forward compatibility. So our internal models are interfaces. And that's good for you because you are using that as a client. So if we decide that our model is not complete and we need to add something, we are just adding a new method to that interface. That's fine for you as a client because you can still build your code against that, right? On the other hand, what will happen if we try to connect and we know, okay, so we are using that new tooling API client at the moment, and it has that idea that, okay, I will be using a model with all these methods, and I'm connecting to an older Gradle build, and that older Gradle build will give me the instance. But that's the old instance. It doesn't know about that method yet. It was created when we had no idea there will be such a method. So what we get from that client is something what doesn't fully implement that interface. So that's why we don't want to have that limitation, and we will use just any object and we'll wrap that with that proxy.
When you say that interface, you're talking about the configuration dependencies model, the one that says say anything?
Yes. So
that works unless you rename your method, right? I mean, it works for certain things, but it breaks down for others. So if you renamed say hello to say anything, then there would be no mapping, right? So is it just that's a certain limitation and it works under certain conditions but not others?
okay, so the question is, how does that work when I'm evolving my model? So yeah, and the idea is that for our built-in models, we are doing that evolution in a way that is compatible for you as a client, right? So that's the restriction that we want to satisfy. Like, you are the client, we want to make it compatible for you so that you can upgrade, and that's fine. So as a part of that, we need to solve that implementation problem, like what we do about those old classes that are not compatible yet with that solution. For most of the cases, if you are implementing your own model, you don't need to care about that. Because it's very likely that you will use the same version of the model and model implementation build at the same time, basically the same jars in the Gradle build, the same jars in your client. Of course, once you do something so widespread as the Android model, you will get into that trouble again. Because you will see that, okay, your clients are using builds that are using an older version of those models. And yeah, so in some sense, if you are successful and distributing your software outside, it will become a problem. But usually for things that are limited and you have control over that environment, you can go without these problems. Sure.
So when you are building custom model, you have to care about this backwards and forward compatibility, which means that you have to grow the implementation in a way it's going to work with the versions of the interface that you have released some time ago to your clients. So it's your responsibility. So, and that's a really cool thing. That's an excellent thing about the custom model. We kind of by using this API, we force you to think about that backwards compatibility. And there is this gotcha with this interface that you don't have to use it, but it just has to work like that. Yeah, and then one more thing I wanted to say is, let me just quickly go to the main class. So this is, what you see here is basically how you embed Gradle with the tooling API. That's the classes that you're going to use. In this particular case, we are loading the custom model, but you could load the existing pre-built models, like give me the IntelliJ project, give me the Eclipse project, for example, the models that ship with the tooling API interfaces. And IntelliJ in their plugin, right, that deeply integrates Gradle with IntelliJ, they're using exactly that. They are calling new connector on the Gradle connector, and they are asking get model, and it's going to be idea project. Yeah, they are asking for idea project. Can't type with my one hand, but yeah. But generally, this is how you use the tooling API. That's how you embed. Yep.
Just a quick question. Do you know if they provide access to the Gradle model through their APIs, their plugins?
I hope not. The question was whether they provide the Gradle models, the Gradle tooling API interfaces, somehow whether they leak to the users of IntelliJ.
Yeah, like if I'm making a plugin that's both an IntelliJ plugin and like a Gradle plugin, and I want to get access to the Gradle plugin model from the IntelliJ plugin.
I'm not an expert on the IntelliJ plugins, but I have a feeling that yes, that the answer is yes.
I think the answer to the question, is it possible to access idea model inside idea when I'm developing my own plugin? And the answer is, it will be hard. You will be depending on implementation details of that Gradle plugin inside idea. And idea is asking for that model, and they are doing few more things inside that plugin to get a little bit more information. So they are asking not only for that model, but they are injecting their own tooling model builders to get some extra informations too. And I think there is no official API on that Gradle plugin as such. So it would be using some internal APIs. On the other hand, yeah, people often do it. Okay.
So I called it a little bit of stuff that could happen in the IntelliJ plugin. So they're asking for idea model. You can ask questions like, what's the language level, for example. You can iterate the modules. Every module has dependencies. And the APIs, the interfaces that you use here, basically they are tailored to the domain of IntelliJ. So basically the names you see is going to reflect the things you're going to see in IntelliJ, right? IntelliJ has modules, as you can see. Modules have dependencies, right? Module have sources. So those are the names and things that you're going to expect, and they will be available on the idea module. So let's see whether there are sources. Get content roots, for example, and if you take a look at the module setting, you have things like, this is the content root, right? That's how it's called, the directory, the root directory for the content. So,
Okay. Okay, one more thing to that compatibility moving forward and backward. Now, what we can do if we say, okay, we are adding a new method to that tooling API, to that model. Okay, there will be a new method, and Szczepan said, okay, if you are connecting to a new Gradle, it will tell you what's the result. if you are connecting to an older Gradle build, what will happen? Very likely you will get an exception like unsupported method exception or something like that. But we can do better. Some of these things are things that we can post getting the model, do some computation and say, okay, maybe that's kind of derived information and we still have a chance to somehow give you that information inside that tooling API. So that's how we are doing some of these things. And we are basically, we can do stuff like you ask for that model with a new method, and that wasn't implemented in that version of Gradle. But if we ask for a different model, we can compute that inside the client, and that's what we will wrap in that tooling API in some cases to pretend that, okay, you are using tooling API of this version, and even older version of Gradle build will now work for you and give you that information.
So it sounded like from the docs that you could also access like the state of a build that had been executed. So how does that work?
Okay, so the question is that we can execute a build and find what was the result. Yeah, definitely. If you take a look at that build launching part of tooling API, there's a way how to get those results. So let's take a look at that. If I will do something different, if I will call new build, I will get an instance of build launcher, and I can say for tasks, run the build. I will pass new result handler. Result handler is basically interface where you can do that processing. If the build succeeded, you will get onComplete called. If the build fails, you will get the failure why it failed.
So is there a model available for like the task execution, like what tasks failed or where it failed at, besides just callbacks?
Not exactly. So the question is there a model telling you why the build failed or what exactly happened? No, we don't have a model that would be providing that kind of information like insight into a build that was executed. To get something like that, I think it would be possible to implement a plugin that will track the execution and then somehow accumulate that information, possibly store it somewhere in the build directory, and at the end you will be, one of these callbacks will be called and you can retrieve that information. That might serve the purpose. It's not exactly giving you the model at the end of the build saying, these are the details, and we went through that task graph or something. No, we don't have anything like that at the moment.
I was wondering more so in that one of the significant gaps seems to be as just builds get more complex is troubleshooting tools. In that one kind of opportunity here is to build like visibility into sort of what's going on with respect to the execution as well as kind of the configuration to make it easier to like figure out what's going on in a complex build infrastructure.
Yeah. So better built inside to get that traceability. That's an interesting use case, and I would welcome to see people contributing in that area. And yeah, I think that's a really nice thing to do.
Why does progress event not have more info?
Go again?
Progress event is a little anemic. Can we get more info about progress event?
Can I say a few words?
Sure.
So, question was about the progress event. Yeah, the events are not yet modeled like richly. So it doesn't say this task has finished. It's just an opaque thing that you can print basically somewhere. But that will come if you submit a request on the forums, or better if you get your hands dirty and submit pull requests. And the earlier question about like more insight into results of the build. So we haven't modeled that yet. So in order to find out which tasks have failed, you would have to parse the exception, sort of take a look into the causes, and then you, from the message in the exception, figure out what tasks have failed. But that would be cool. I would enjoy that feature in Tooling API very much, where when the build is finished, I receive some object that tells me how long did the build take, for example, what tasks have failed, maybe some profiling information about the times and things. So yeah, that would be something cool. And this sort of things, you can't have them with the custom model. The custom model, which we are discussing during the presentation, is related to model building and not related really to executing the build, executing tasks. Because building the model is a different thing than executing tasks, really.
Let me add one more thing to that topic. Yeah, designing the progress listener is one of these things when you are doing something what will be there for a long time, and you are not sure at the moment what exactly, how it should be shaped. That's why we are using incubating annotation in a lot of places like this. And yeah, definitely the better traceability for the build, giving you more information, including like the build is running, what task is running. If tests are running, you would like to give you much more complete information about what tests were running, how long did it take, give you the output without letting you to scrape the output directory from those tests to see what happened there. How much time do we have? Ha. The demo had like 4 stages and oh. Let's do it more quickly.
So can I just say one more thing about the custom model?
Sure.
So the interesting thing about the custom model is that custom model is a Gradle plugin. It's nothing else. So traditionally Gradle plugins introduce tasks, introduce new DSL, new language elements, or configure existing tasks. The custom model plugin is also a plugin. It's just it does not add any tasks. It could, right? But it registers those new models that are available through the Tooling API.
Okay. I will guide you quickly through those build scripts, and we will skip some of these things to show what you can get. So here we have a build script for the dependency plugin. To build the plugin, you usually need to use some of the Gradle APIs. So the dependency will likely be compiled, depends on Gradle APIs. We are publishing the artifact that is built by this project to make sure that the sample project that we will be using for that will be able to access that jar and have that model ready when it's executing. So we will build the plugin, publish it into that IVA repository. And now, if we do that, we can do. Do we have Gradle on ClassPass? Yeah. Nothing special. It's basically empty, but it can run. It has the access and the dependencies plugin was installed there. That's the one. Now go back. We did some changes to that source code, right? Okay. At the end, we got our hello world, at least. So I will move a little bit forward. We went through these things. We defined a plugin, we designed a model interface, we registered our model builder, we added the implementation. Through those steps, publishing the dependencies plugin and running the client, we saw that, okay, now our client code was able to call that Gradle build and got the simplest model that we have. Okay, in the next step, I wanted to wrap it into a web application. And I wanted to do something more real with that project. The idea was that I will get a project instance that's our Gradle API project. I will ask for configurations and their dependencies, and I will create a simple graph of these dependencies, and I will create a simple web page showing those dependencies. There was a shortcut using some of the internal classes that are used in the dependencies inside task. Now, fast forward to yeah, where is that? Gradle refresh failed. What idea do you have?
13 something, I don't know.
Huh?
13 something.
Well, it doesn't like our. Okay, anyway. I changed the model to serve some real data. The builder is now more complex. What is interesting here, when build all is called, you get an instance of that project. That's basically what you can use when you are building your own model. And from the project instance, you can get to many things. So I will not spend much time on these details, but let's look at some other interesting things. Okay, because I wanted to show it in a browser, I added Jetty server dependency and wanted to run it with embedded Jetty. The interesting part is here. If I say that my dependencies plugin is depending on Gradle API, it gets a lot of dependencies. It will depend on Gradle core with those APIs. It will depend on some implementation classes transitively through that dependency. This is not what we want when we are building that client code. So here I have only tooling API to be able to connect to that Gradle build, and I have dependency on that plugin code, and I say not transitive dependencies. I can solve that thing a little bit differently. I can create a separate library with those models and keep that library without any extra dependencies, just to make sure that you really build just against that model and not the stuff that is internal in Gradle implementation. So in this particular case, if I remove that transitive equals false, I will get a problem that somewhere through those transitive dependencies, my code will get a dependency on a different version of Servlet API because that's in one of these Gradle plugins somewhere.
Basically, we just want the interfaces that make the model, the custom model. Don't move anything else from that.
Yeah. And yeah, if you do it that way, it will keep your code clean. So, not a big deal. And now let's go to that last step. How to make that more effective. Because we did something where we enhanced our build to get the insight into that build. We had to apply plugin dependencies and have that build script section in our build. That's something what you don't like that much because you are building something and you want to apply, you are building a tool that will collaborate somehow with Gradle, and you want to make sure that this tool can be used with any build. And you don't want to force people, okay, so if I want to be able to be used from your tool, I will have to apply your plugin. Oh, why? Does it mean that now every time I do a new project, I will have to do that? So the solution for that is you can use init scripts. The advantage will be that any project that you can see on your disk, yeah, and Gradle can build, yeah, you will be able to see that information. You will need to solve that class path problem, right? And we will create the init script dynamically, basically the same thing that IDE is doing, and we will run the model builder and say, okay, use that init script, and that init script is basically doing the part where we say, okay, for this project, apply that plugin using that class path. Might be simpler if I fast forward to that. Oh. Did I? Oh. This is the template for the init script. It says, with all projects, do that stuff. Add a repository and the build script will have a dependency on something what is in that repository. And once after evaluate is running, we will apply our plugin that will inject our model. The side that is calling the Gradle API, basically at the beginning, we create that file with the init script, and when we are actually calling the connection to get the model, we pass an extra argument saying, hey, init script is living in that path. So definitely IntelliJ is using that approach. NetBeans is using that approach. I'm not sure about Eclipse. It's possible that they are using something similar. And for sure, Android Studio will do something similar too. So,
can I say something? So without that trick with init script, every Android application would have to configure this sort of an internal plugin to make the Android Studio working, which is not desired. We want you to have Android applications and Android builds without those internal details. And by the fact that when Android Studio loads the model for the project, it uses the init script to extend your build and add some extra stuff, add extra plugins. Those extra plugins provide the custom model, custom Android model, and then that's how the Android Studio can work.
are you really sure about that? I think their custom model is in that when you apply Android or Android library plugin, that's where the model is. But I think what they are doing, they ask for not only the Android project model, but they ask for IDEA project model as well. And if they are doing that, they are very likely asking for other stuff that IDEA is doing too through those init scripts. Because what they are doing with init scripts, they are registering other models that help them to get more information about the build script, and that improves the Gradle editing support. If you are editing a Gradle file inside IntelliJ, they know a little bit more about that build file just because they ask for information from Gradle and they get it through the tooling API. This is a demo from Light Table Editor. That's something what we were asked about recently on our dev list when Magnus said, okay, I would like to do some integration for this Light Table Editor, which is not such a heavyweight IDE like IDEA or Eclipse, but we are doing things in a little bit different way, but I would still like to be able to show some of these things from Gradle to our users. So in the end, he did a really similar thing to what I wanted to present here, and that's the output that he got. He got the rendering of the test compile dependency for that project. So doing the same thing, building his own model, exposing that information from the build, asking from the Light Table process and rendering that in this application. How much time do we have? A little bit. Maybe I can mention some of these things that we want to do. Cancellation in tooling API is not implemented yet. That's one of these things that are on the table and are likely to happen pretty soon. So some of these actions that you will do through tooling API are obviously taking time. So we want to implement cancellation. Build can take a time. Analyzing information about your project can take a time. How much time does it take for LinkedIn guys to build IDEA project?
Depends on the project. We're talking about this huge project, and yeah, it's taking a little bit.
Well, we gave up on the project. We just wrote our own to match it into a simple class.
Okay. So yeah, having cancellation for these things makes sense. More information about builds. That idea, yeah, I've heard that from other people here in the hallway, that having more information about what's happening when I'm building something and I cannot get the expected result and I need to debug that build, that's useful. So yeah, if we can expose some of these things through any way, it can be tooling API, it can be something slightly different. Yeah, I see that there's a valid use case for these things. Possibly longer term two-way communication. There are things like Gradle wants to know that, okay, something has changed and we need to reload that project. And those are some of these advantages that we are using Gradle daemon, right? It's in the memory, it's running for a longer time. And yeah, we already did some work. So if you make several requests, it's likely that we already did some processing for you and we can take advantage and give you the information more quickly. But we can go even beyond that point. And for example, if we notice that, okay, the project is changed, the Gradle file is changed and we have to reload and rebuild that project, maybe there will be a possibility in the future that perhaps we can notify your client that you asked for a model, but definitely that model is not valid anymore. Improving models for the IDE integration. We have that topic showing up in various places, and one of these things, we started with Eclipse project and IDEA project, and now we see, okay, the Android project is really a different thing. And now we are learning what are the differences and how we see a path how to converge them again into something what we will use as a common part for all these IDE models, and we will create something what's shared between those models and build the specific domain-specific parts on top of that. As we will do that stuff, yeah, you can expect improvements in the current IDE plugins, because we want to make sure that if we are doing something on that front, it will be used as quickly as possible.
So I just want to tell you a little bit about this two-way communication in the future. So an example of that is that, for example, a dependency have changed in the build script. I don't know, someone bumped to a new version of Mockito once it gets released. And then...
It's happening frequently.
Very frequently, yeah, indeed. So what we want to have is that the model, the client gets notified that this dependency has changed, right? So, and then something can happen in IntelliJ, can just pick up new dependency, and you don't have to, the user does not have to hit explicit refresh. So that is an example. And for the cancellation one, imagine that you have a cold cache, right? And you, hey, give me the IntelliJ project model. So it's going to have to download all dependencies to build up the IntelliJ model, right? Because we need dependencies for the modules. And it's taking time. And currently, you don't have any way to cancel that operation. So basically, it's going to happen until you kill the client completely, or do kill all Java or something. That'll do. So you want to have a high-level, nice API for cancellation. Yeah.
Okay, questions?
If you guys are doing like two-way dependency communication, could a plugin use that, say, for example, like the locking version feature, like just send a message to Gradle, say, hey, set this version of this dependency in your file equal to a specific version? So
the question is, if we decide to do that two-way communication, will it be something where you can negotiate on those notifications? And I think it's even more complex than what we are seeing as a possibility now. It might happen, but not anytime soon, I'm afraid. Hey, no more questions at the moment. I think we are over time now, right?
We have 15 minutes.
Oh, we have 15 minutes. Okay, that's excellent. let's do that.
You mentioned that if it didn't have the distribution, that the tooling API would go off and down with the distribution.
Right.
Is that the same logic as the wrapper doing it? Is it same code, different code?
It supports the wrapper, and since we encourage every build to use the wrapper, yeah, it's just going to use the wrapper. So,
So it does refer to the wrapper jar?
um,
I'm going down the road of if I didn't have the actual wrapper jar there, but I had the tooling API jar, is that enough for it to?
it's it depends how the client implementation is done. If because okay, so give me specific. I'll give you a specific example. IntelliJ, when you import a project into IntelliJ using this new deep integration, and let's assume that this project of yours don't have the wrapper configured. So then in IntelliJ, you would have to select the version of Gradle. And then what IntelliJ does behind the scenes, this Jet Gradle plugin, is going to, instead of using, basically, this, not sure if you remember this code, a project connection, give me connection, it'll just say, give me connection, use this version of Gradle located in that directory. So it's going to use the information you've provided in the forms in IntelliJ, where you typed version of Gradle and location of Gradle. Make sense?
Okay. This is the Java doc for the Gradle connector, and yeah, I think these methods can be mapped to that import wizard that we are seeing now. Yeah, that's this. Use wrapper. Use the default Gradle wrapper. I think this one matches to not calling any of these methods, and as a result, the fallback is that the same Gradle version as the API, as the tooling API version will be used. Use local Gradle distribution and set the Gradle home. Setting the Gradle home, yeah, that's one of these things that people sometimes want to do in their IDEs to make sure that the Gradle cache is collocated with the project itself or with the IDE. So yeah, there are still some things that we need to polish in that area to make sure that it's working better for you. Okay. So I cannot get this one in because of that bin tray. Okay. Never mind. Yeah, that's my error because the build script expects that there are some properties defined somewhere and they are not there. But I can do this thing. Oops. I'm not a Mac user, so I don't know these shortcuts. I took that from Ben, and there's a similar code in several other repositories for various Gradle plugins. So the idea is that I have a plugin that is building a NetBeans RCP module. There is a plugin building Eclipse bundle. There are other things. We want to test that. As a part of that test, we will create a simple project and basically run a build on that project. And that test fixture will do something for you, and you will be able to run some tasks. And to run a task, you will call Gradle connector, give me the connection, and the project directory is something what we have created inside this test fixture at the beginning. And we will connect, we will run the build using the tasks that are just passed, and then we can inspect what's the result. So that's the simplest idea. You can do some other things, like if you know that you don't really have to run a build, but maybe you will be testing your own model, you can ask for that and do similar things. So yeah, that's...
Can you show one of the tests that uses it?
Definitely. What edit? This one extends the one that we have seen before, so we will run task NBM, that's NetBeans module or something, and after that we will assert that, okay, if we run that task, we know that we set up the build correctly, so we expect that the output file will be there. Of course, we can do more like those things that we have mentioned. We can verify that the build really succeeded and make sure that on success was called and not on failure, and be more precise about these things. But for the purpose of getting idea, I think that.
I just can't help point out that there's a version of this or more fleshed out from Luke's Gradle test kit that's available in the plugin portal right now called Idea Test. So yeah.
Okay, so
Can you promote that now?
the notice was that we have a test kit available on a plugin portal at the moment, and part of that is the effort from the Nebula project, right? Great.
So you use that until we provide awesome testing suite that's happening soon, I hope. Because yeah, that was my mission when I joined Gradle. As a testing guy, author of Mojito, I wanted to have a beautiful way to do integration testing with Gradle, and it hasn't happened yet, but it will.
It has. In core, it's there.
In core, it is there, yes. So, because we want to encourage more contributions. If you want to write decent integration tests for Gradle, you have to contribute code to us and work on our features and our bugs. Then you can take advantage of that awesome test fixture code. Right?
Exactly right. Yeah. Okay, questions? Okay, if you don't have any questions, then thank you. I hope it will be something useful for you, and I hope to see some use cases in the future how this can be used, because building on top of that, yeah, you really like to see how other tools get integrated with Gradle. Thanks.
Thank you, guys.